Hello, ninth graders. So we are starting our last lesson of the year, which is pretty crazy. So this lesson kind of talks about we're getting a little bit further into probability, a little bit more complicated processes, but we're going to talk about different ways that we can incorporate strategies in order to make these processes a little bit more easily understood and accessible. Okay, so we have this idea of independent versus dependent events. Remember that independent events are events that happen independently of each other, that the result of one doesn't affect the result of the other. So what's the probability that if I'm pulling, the basic example is if I have two, like a bag of marbles and a bag of coins, what's the probability I'm going to pick out a red marble and a coin that's a nickel or a €1 coin? Those are completely independent and their probabilities are going to be separated as a result. Versus dependent means if you're pulling from the same bag of marbles every time, or maybe you're pulling from the same amount of people every time. And the idea of like people getting less and less, the number of people or the number of marbles that you're picking from is less and less. And so you need to make sure that you adjust your numbers as a result. It looks like a factorial type of situation because it is. So remember that we have the multiplication formula for probability here that we use for independent. We also use it for dependent. We just need to make sure that your second probability that you're multiplying by has this idea of the given that something has happened before. So we would say if B depends on A, then the probability of A and B happening is equal to the probability of A happening times the probability of B given A. So a classic example is marbles, or we can talk about jelly beans. So you've got a bag of 10 Bertie Bott's every flavored jelly beans. There are 6 that are vomit flavored, 1 that is earwax flavored, and 3 that are cherry. If you draw one bean and then eat it and then draw another one, what is the probability that the first is vomit and the second is earwax? So this is a dependent occurrence because the number of beans left over changes as you're pulling it out. It's still multiplication because we're talking about and. So one bean and eat it. What's the probability that the first one is vomit? If 6 are vomit flavored out of a total of 10, the probability is 6 over 10 times, and now realize we have only 9 beans left. And then we want the second one to be earwax, and there's only 1 that is earwax. So the probability is 6 over 90. And that's it. If you grab 3 beans simultaneously, what is the probability that they are all cherry? So for this one, it doesn't have a specific order that you're pulling them from, but it's still this idea of what's the probability that the first, second, and third one are all cherries. And so since these are all the same flavor, we can just do these all like how we did the previous problem. So we have 3 that are cherry. So the probability that the first one's going to be cherry is 3 out of 10. The probability that the second one's going to be cherry is there's only now 2 cherries left out of the 9 that are now left in the bag, and then 1 over 8. So 6 over 720. Yeah. Okay, so we're going to do this again, but now you're going to see that we're going to start to talk about something that's a little bit different. So in a collection of 8 Bertie Bott's every flavor jelly beans, 3 are tripe. If you take 2 beans simultaneously, find the probability that they are both tripe. So then the first one would have to be 3 out of 8 times, and then the second one would be 2 out of 7. So that would be 6 out of 56. What about the probability that neither of them are tripe? Well, if 3 of them are tripe, the other 5 are going to be non-tripe. So you would do 5 out of 8 times 4 out of 7. So your probability there is going to be 20 over 56. What is the probability that one of them is tripe and one of them is not? Notice that with this question, there is not a specific order. Like they're not saying what's the probability that the first one is tripe and then the second one is not. They're saying what's the probability that only one of them is tripe. So realize you could have either tripe and then non-tripe, or non-tripe and then tripe. So you have 2 different situations that would fall under this category. So you need to find the probability of both of them, either or, and then add them together. So we're going to multiply to find the and piece, right? 1 tripe and 1 not tripe. And then since there's 2 situations, either this one or this one would fit that category, then we're going to add those 2 together. So the probability of the first one being tripe would be 3 out of 8 times, and then the second one not being tripe, there's still 5 that are not tripe, but now only 7 in the bag. So that's the first one being tripe, and then the second one being non-tripe. And then our second option is that the first one is not tripe, so 5 out of 8. And then the second one is tripe. There's still 3 tripes left, but only 7 left in the bag. So then this is tripe and then not tripe. So with these 2 probabilities, you find the probability of each of those events occurring. And since both of those events fall under this category, you add those probabilities together. So that's going to be 15 over 56 for both of them. So it's going to be a total of 30 over 56. When we have non-order specific probabilities, like what's the probability that the first one is this and then the second one is that, when we don't have that, when we just say what's the probability that one of them happens to be this, we have multiple ways to be able to approach it, but a lot of times we talk about it in terms of a tree diagram. So we're going to model this question now with a tree diagram. With notation, T will be tripe. We tend to have this notation with like this apostrophe up top, and that means not that. So T with an apostrophe is not tripe. And we use that in probability notation all the time. It just means not of that version. So if we were to then draw our tree diagram, we first say, okay, well, we have the probability that there's going to be a tripe, and then we have the probability that there's going to be a not tripe. The probability of us going from the beginning to tripe is 3 out of 8 versus the probability of going to not tripe is 5 out of 8. Then if I went down the path of tripe versus, if I went down the path of tripe, then we have 2 options for the second one. The second one could either be tripe or not tripe. And again, now we can find those probabilities. With the second one being tripe, that would then be 2, because there's only 2 left out of the total of 7, or still 5 left out of the 7. Versus down here, if we went not tripe first, and then we could have the option of tripe versus not tripe, there will still be 3 tripe left out of the 7. Or now there could be 4 non-tripe left out of the 7. This is a tree diagram where we mark out all of the potential paths that could happen given a certain number of choosings. And then we find those probabilities as we move our way down the probability chain. So if I were to then say, okay, find this probability using a tree diagram, you would build up the tree diagram and it says, what's the possibility of you pulling exactly 1 tripe and 1 non-tripe? That would be either this path or this path. And how you find the probability then is follow those paths down and multiply them. And then add them together, just like what we did above. So let's practice that.